books with international or national publishers. He has also published 2 patents, one in the solar dryer and another in the solar photovoltaic thermal collector. He has supervised 7 PhD scholars, 33 master students. Dr. Kumar has also visited countries namely UK, Thailand, and Malaysia. So, sir will today give his lecture on the topic implementation of solar thermal energy in industrial process heat. So, I welcome sir to present his topic. Please, sir. Yes. Sir, can you please share your screen? Anil, sir.
Yeah, I will share.
Okay,
Just
thank
a
you.
minute. Yeah,
Thanks.
thank you, Devin. Thank you very much for convener, coordinator, and pattern for this sponsored 1 week workshop on the vision, scenario, and future pathway towards the sustainable development. Definitely, this is the burning topic for today scenario. We all care about our energy requirement, as well as at the same time our responsibility, our social responsibility for the to protect our environment also, right? So energy, economy, environment, and I was also there in your this inaugural session. So I was listening chief guest and other guests. They were very much emphasized on the sustainable development. Definitely, it is our urgent requirement itself, right? So again, I am thankful to Dr. Prashant Singh Chauhan, Dr. Devin Singh, Dr. Vikas Palle, and other coordinators, and the pattern of this program, Dr. Anil Kumar, principal, Gaya Engineering College. So task has been given to me. Show full screen. So now, what happened? Open to share. This, okay. Fine. So, can you see my screen over here?
Yes, sir.
Okay. Okay. So, is it fine now?
Yes, sir.
Okay, thank you. So, my talk is on implementation of the solar thermal energy in the industrial process heat, right? And generally,
Sir, hello. Sorry for interrupting, sir. Sir, your voice is not so much audible, sir. Can you please?
is it? What to do? So just a moment. I think my now is it fine or better?
Yes, sir. Fine.
Okay. Thanks. Notice in the beginning itself. Otherwise, so now, okay. So now it is audible also. Now let me check other things. Okay. So organizer has given responsibility to me to talk on the implementation of the solar thermal energy in the industrial process heat. As we know, industrialization of this of any country is very essential for the in the present scenario, because all of us we want development, right? So, and the energy is distributed in the many manner in the many sector itself, the domestic, commercial sector, like in that way. There's our industrial sector also, right? So now, yes, yeah. So I would like to discuss Of course, first the India's energy and renewable energy contribution or the scenario and about the position, right? What is the government has set the target for the generation of the electricity from the renewable energy itself. And then I will talk about the industrial energy consumption statistics, how the industrial energy consumption is distributed in the various things. In fact, I will emphasize on the process heat only, and then how we can implement the such a requirement of the industrial requirement through the solar energy itself. And our basically our solar collector is these are the main devices for the conversion of the solar radiation to the solar energy, and whether it could be uh, photovoltaic or it could be the solar thermal. But here I would like to emphasize on the solar collectors, the thermal aspects only, right? And the various range, temperature, and all the industrial sector. I will give you some example itself. So heat requirements the industrial application of the various process, of course. So this will be, and in fact, if I so in that way, my talk will be divided into basically the three parts. First, I will talk about the renewable energy, then the industrial energy requirement, and how we can implement with the help of the solar energy with the various equipment of solar energy, and then some industrial processes also. And among that, I would like to speak about the solar drive, the industrial solar drive, right? So since morning, people are talking about this sustainable development. Of course, without mentioning, really, it is very difficult to talk about the renewable energy vision scenario and all the field sustainable development. In fact, so this is basically just what we have to care about our future generation. Okay, future generation in what manner? Like what we can do over here, like the preserve the present in the environment and the preserve the resource, right? So what the way for doing so, all these practices, how can we uh, preserve the environment and the present energy resources, and basically the thing is the optimum use of energy in the right direction. So means the energy efficient devices or the energy conservation uh, practices we have to follow in our daily life, and in all the sector, domestic, commercial, industry, all agriculture, and all the sector. So by that way only we can save our energy. And in fact, someone has already said the energy conservation is itself a energy production, right? And at the same time, all of us know, for the caring the environment, we cannot stop our industrial development, right? For energy is the prerequisite, or the energy is our essential requirement for the development, and development of means right development of a nation, the per capita energy consumption. In the morning itself, the one speaker was talking about the this what is sustainable development on energy consumption, and basically the this what is called uh, means the social economic growth without the degradation of the environment. Definitely, we have to take care over there. This also. So India has also committed about the intended internationally determined contribution. This is to the UNFCCC uh, during the 2020 itself in climate action, and our Prime Minister Mr. Modi ji has already committed to the international society, right, for the to install the 175 gigawatt of the renewable energy power capacity by the 2020 itself. Earlier, it was the 100 gigawatt only, and in fact, it is a revised value by the setting the new target to increase the country share the non-fossils base installed in electric capacity to the 40% to 20 by the 2030. So right now we have the share around the 23% of renewable energy in the total generation of our electricity. So it is a good of course, the government of India has already said this. Among the breakup of this 175 renewable energy installation is the 60 GB from 60 gigawatt from the wind power, 100 gigawatt from the solar power, and you will be happy to know about out of the 100 gigawatt from the solar power, already 85 gigawatt has already been installed by the end of the December, by the end of the 2019 itself. 10 gigawatt from the biomass power and 5 gigawatt from the small hydro power. So India's greenhouse emission intensity per unit GDP means we want to reduce, and we are basically committed to reduce this GDP by the this greenhouse emission intensity per unit GDP by the 30 to 35%, which is the below level of by the 2030, right? So, and in addition to this, the carbon sink of the 2.5 to 3 billion tons of the carbon dioxide to the additional 3%, right? So these are our commitment to the international society, and it is not a kind of the commitment to the international society. It is the commitment to ourselves itself. Okay, we want sustainable development. Okay, that's why although the cost of generation of electricity from the renewable energy is compared to the conventional energy source is much higher, but still we are emphasizing for the enhancement of the share of that renewable energy in our the energy production, right? So, and talking about the solar energy, and if we not talk about the national solar mission, so it will be the incomplete task. So in fact, this national solar mission was started in the January 2010, right? And the first mission to be operationalized under the National Action Plan of the on the Climate Change (NAPCC), and it was this national solar mission will be implemented in the 3 stages, right? So the initial target of the mission of the installing the 20 gigawatt grid connected solar power plant by the 2020, but it was achieved so early, and in the 2015, later the government of India has decided to revise its this figure. Was enhanced to the 100 gigawatt to be achieved in the same year by the 2022. So by the end of the 19, I have already told the 85 gigawatt has already installed from the solar energy itself, right? So till the December 2019, this is our source-wise installed power generation capacity. So just look at over here, the total generation of the electricity in terms of the kilowatt hour. It is around the 3 lakhs 3,65,000, right, kilowatt hour. So out of that 2,30,000 is it is almost the 63% share of the conventional energy itself. This coal-based power plant definitely that we cannot stop electricity generation through the coal itself, because we want our industrial development also, we want our development also. At the same time, we are working on the renewable energy resources, installation of the renewable energy resources. Right now, it is the 23%. It is a very handsome value. The 23% of the total power generation is the 23% from the renewable energy itself. Then 12% is hydropower. However, it can be more. This share can be more, as we have a lot of potential for the small hydropower like the 15,000 megawatt itself, but the harness is very less. So we can also work out on this sector itself. The way this nuclear power is 2% only, the share of the nuclear power. And for a long time, almost the last 20 years, I'm just noticing this amount is not increasing. That doesn't mean we stopped our nuclear programs. It is not stopped. Of course, our day by day, our generation capacity keeps on increasing. So, but the rate of power generation from the nuclear energy side is little bit less. The pace is less because of that reason. It is still stagnant, or you can say that it is not more than the 2% and so far. So this figure is just to show you our share for the renewable energy side, right? And like of course the estimated potential for the renewable energy, India is dependent. In fact, what at the same time the this our lot of the money is goes to the goes to the imported fossil fuel, so that we can reduce as we have the lot of the renewable energy potential, solar energy, wind, biomass. We have the lot, and even the small hydro also, right? So so this is our estimated potential. The and the total estimated potential of the renewable energy, the 1096 gigawatt for commercially exploitable sources, right? So, and out of that, the wind energy having the 302 gigawatts at 100-meter height from the Earth surface, right? And the small hydro is 21 gigawatt. Earlier, this figure was estimated was only the 15 gigawatt of the 15,000 megawatt. Bioenergy 25 gigawatt and 750 gigawatt. This is the highest for the solar power. The reason is because we are residing on the what is called India's position. Our position is the 23 point, means very near, and we are quite blessed with the solar energy itself because of our position in the globe, on the map itself, right? So this is all about the renewable energy. And now, yeah, one more thing, that 85 is already been exploited by this, and India has the fourth and fifth global position in the wind and solar power deployment respectively. And in fact, the solar power capacity has increased by more than the 14 times in the last 5 years, the 2,630 megawatt to 37,505 megawatt in the December. This is the 14 times in the last 5 years. So just to see the how, and in fact, at the same time, I would like to mention one more thing, like our power factor of renewable energy systems. That is very poor. Although this is the installed capacity, but actual in that I will talk to you later after in between some my slides itself. So sector-wise, renewable energy cumulative achievement till the December 19, the highest is the wind power itself. This is the 37,505. Then solar power, ground mounted for solar photovoltaic. This could be the ground mounted. This could be a rooftop. This could be the floating type. So various kind of this solar power can be generated. And in fact, this is especially solar photovoltaics. Most of the share is from the solar photovoltaics. And one more thing I want to mention over here. So in implementation of the solar photovoltaics, of the solar power generation through the solar photovoltaic is not totally the independent, independent activities. Like unfortunately, our most of the solar photovoltaic systems are imported from the China only. So still our solar power generation is dependent directly from on the China itself, right? And a few companies like the BHEL and the Tata, they are fabricating, but not as much as much as our requirement to fulfill our requirement. So this is the major our concern. We have to think over on the solar photovoltaic module fabrication and all the facilities, right? So, and that can be checked. That can easily be checked through any sources, like all our big plants in the capacity of the 2,000 megawatt plant, photovoltaic module, right? So that is the if you want total independence, means we don't want to be dependent on the other side, whether it is the fossil fuel or the photovoltaic. Then we have to develop uh, for for the installation of the renewable sources. Okay, in that way, the small hydro is still very less, though we have the installation potential is 21 gigawatt, but it is very less. So in that way, so 85,908 is the megawatt from the renewable energy only uh, by the end till the end of the December 19. So this is and in fact the top 10 state in the solar installation. The Karnataka, the south, you just although uh, this Rajasthan and okay here Jammu Kashmir is not there. So Jammu Kashmir, Rajasthan, they are the state which have the lots of solar energy generation potential over there. So Karnataka is the topmost over there. The 10 state statistics over there. So yeah, this is a very important slide because we are like in India, we are the developing country, right? So just see our installation capacity in the 19, though it is quite old, we have the data only the 2013 itself, but I want to give you one message, like our in the 2000, in the 1900, at the time of independence, the was only the 1362. Just see our development in the last 70 years or 75 years or 72 years. Just see our development. Our requirement, our install capacity is keeps on increasing, and in fact, this installation capacity keeps on increasing. That means our requirement is also increasing. Though the demand and supply is mismatch is there, but it is keeps on reducing day by day, right? So my intention is to by showing this slide is just to see the imaging and shows the industrial development. So how the industrial development is taking place in the last 70 years. If someone is saying that India has not done anything in the last 70 years, nothing has been developed, nothing has been, so it is not the good idea. Okay, so everything is picture is very much clear. In the same way, just to see over here, this is the per capita electricity consumption in our country. The 1947, our population was around the 30 crores, right? Now we have the 130 crores around, and by the time we have only the 30 million or the 30 crores. So per capita energy consumption was only at the time of independence 16.3 kilowatt hour. It is not the megawatt. This is kilowatt hour. And by the end of 2013, it was the 917, and right now it is around 1200 kilowatt hour. So per capita energy consumption doesn't mean like in my house we have the 4 people, right? And our electricity bill is the 200 kilowatt hour per month, right? So that doesn't mean our per capita energy consumption is 50 kilowatt hour each. So it is that is not the way. So actual in morning, the one of the speaker was talking about the energy consumption in all the aspects, like for calculating the how much water is required for the shirt, t-shirt, and all. So that is basically that means if this energy consumption means whatever I'm wearing over here, like my shirt is there, pant is there, and watch is there. So means uh, it is the overall consumption basically, including the industrial sector itself. So it is not the individual, right? So that means that whatever the energy is consumed and right. So in that way, so just to keep just to see it is keeps on increasing definitely, though there are millions of the villages are there, they are still very electricity is not reaching to them. So of course the renewable, because maybe some reason it might be the transmission distribution losses also there for the interior remote area and the tribal area. So there the renewable energy installation is a better option, right? For to improve their lifestyle. So per capita energy, electrical energy available, and the mid-year calculation. Fine. So in that way, this is the rough estimation, and it includes the everything, the all kind of the consumption, consumption in the country. Okay. So one more thing, the conventional power distribution, as we all know, the total losses. Suppose coal-based power plant is very less efficient. Okay, 33.3% efficient power plant is over there, and it is the 1 kilowatt in electricity is produced, and there is transformer and the switchyard losses, then the transmission and distribution losses over there, right? 10%, the 20%, and at the end, at the consumer, you will get only the 0.72 kilowatt hour of this one kilowatt hour, whatever the electricity produced at this point, and we are getting the only this much of quantity, right? So this transmission distribution losses in India is very serious issue, right? And the transformer and the switchyard losses we can reduce with the help of the technological upgradation. But this is really very difficult to overcome this problem. We have to be aware ourselves only, then only it is possible. So to protect our environment, we have a lot of uh, for the fossil fuel based power generation, uh, right? So we have this carbon dioxide is emitted at the 0.998 kg per kilowatt hour. So this much of in per kilowatt generation means this much of energy, this much of carbon dioxide is emitted. And like in that way, the sulfur, nitrogen oxide, soot, and SPM, and all. In fact, so major my concern is about this carbon dioxide. Although all the components are necessary for the to protect our environment, right? But so just to see over here, so these problems we can avoid with the help of the by using the renewable energy sources. So CO2 mitigation potential. Though this slide is very this paper was published by the Professor T.C. Kanpal in the 2007, and now lots of the things are revised. But still, if suppose we consider this much only, so we have a lot of CO2 potential by the renewable energy sources. The wind 36,000, around the small hydro 14,000, biomass this much. So this is the billion tons per year. This potential is the billion tons per year. So this is the huge amount, and definitely, if you could able to utilize all the potential resource of renewable system, definitely we could able to contribute for the clean environment, right? So definitely there are for the human activities requirements, you can broadly divide into the major area. These are major area or domestic, transportation, agriculture, industry, right? So in this way, we can whatever our energy production is consumed in the different sector, and in fact, the consumption of more energy in the country indicate more activity in this sector, right? The consumption is more means that means definitely our more activity in the, suppose the consumption in the domestic sector is increased, that means the better comfort at home due to the various appliances. Microwave is there, right? Geyser is there, water geyser. Definitely, we are living the better life as compared to over 60 years back. So, a better transport facility, definitely better transport facility in now. Many people can able to fly, okay, and they can like in all the metro city, we have the metro. So definitely we have the better transport facility and good AC buses are there, and so this kind of the upgradations are there, and more agriculture and the industrial production, and also at the same time in more agriculture production means grains, vegetable, and our agriculture producers are more, and major most of the responsibility is the farm machinery practice, and as well as our definitely the fertilizers, right? And fertilizer also very energy intensive product. We need the lots of energy and water, and again this farm machinery product also run from the energy itself. The electricity is being used for the running them, and at the same time the industrial production, right? So all these consumption directly reflect about the lifestyle. Okay, so we can say energy is a fundamental input and industry essential need for the advancement, modernization, and economic evolution. Look at this picture. This the few countries has been shown over here, and they are the industrial energy consumption statistics. Okay, so of course China, everybody knows China is a 70%. Means this shows the percentage that whatever the energy consumption in their respective country, the total share. This is the total share. This is the share from the total energy consumption or the industrial activities only, right? So energy used in the industrial sector, 70% of the total energy consumption in China. On the other hand, the Germany, of course, this is the developed country and this is the developing country, and China will not be anymore the developing country after this pandemic. Uh, after At the end of this pandemic, this China will be developed country definitely, and that I my personal view over there. So at the same time, just you see over here, the India's industrial sector consumption is 45%. It is means among all the four sector: domestic, commercial, agriculture, industrial. Among all these four sector, India's consumption is 45% of the total energy consumption annual. Okay, so and if suppose we talk about the world annual energy, this is around the 35% world so 35%, so more than one third, on an average more than one third part of annual energy consumption is share for industrial sector only, right? So as I already told, the advancement, modernization, and economic evolution of any nation in the industrial sector that directly reflect from there itself. So industrial sector of any nation has a significant impact on the economic growth. Of course, the GDP means energy consumption is there, GDP is increasing like that way. So about the 30 to 35% entire growth is consumed in the industrial sector. Energy consumption is about in the range of the 28 to 70 of these country, among these countries. However, this could be the lesser in some poor country also, right? These are very latest data, so we can rely on this. So now just talk about this industrial energy consumption statistics. So out of this, I suppose the 30% is the industrial energy consumption, means 32% industrial energy consumption on an average. So just to look at over here, the more than 70 out of this 32%, more than 74% of the industrial consumption is used for the process heat demand, right? And then the second one sector which consume the highest energy consumption is there, that is your transport sector, then domestic or residential domestic, and the 13% for the others, right, including the agriculture and all, right? So now here, just look at this picture. Out of this 32% share, the 74%, 32% of the industrial energy consumption go out of this 74% goes to process heat only. And among that, further it could be bifurcate and according to the quality of the steam, means the low temperature, medium temperature, and high temperature heat. So low temperature heat is the share for the low temperature heat up to the temperature of the 150 degrees centigrade. It is the 30%, right? Medium temperature 22% share is there, and the range of the temperature is the 150 to 400 degrees centigrade. And the high temperature is around more than the 48%. For the temperature of that process process heat is 400 degrees centigrade. So just look at over here, up to the 400 degrees centigrade, we can easily achieve with the help of the solar thermal applications, solar thermal devices. However, it is not so tough to get to fulfill the high temperature heat energy requirement. So it can also we can do. Okay, we can also incorporate for the high temperature applications also. And just have a look at all this. For any developing country, agriculture, textile, pharmaceuticals, food processing, dairy, and brick industries are the important subsector, right? And the operation involved in these sectors are the drying, dyeing, boiling, washing, sterilization, and pasteurization are the important sectors, right? And for the most energy intensive industry like the steel, glass, ceramic, because these industry having the high temperature applications, right? So, so energy consumption in these industries around the 30% of the industry process implemented needed low temperature thermal energy up to the 100 degrees centigrade, whereas the 20% to up to the 200 degrees centigrade, and the existing need are very high. So in that way, I mean to just to say means the energy consumption and means emissions are directly linked. Therefore, the increase in energy consumption will lead more emissions. So that so far we are using or we are fulfilling our energy requirement for the process heat is from the electricity itself. So what we are doing over there, the first we are producing electricity with the help of the fossil fuel, right? And it could be the it could be the coal, it could be the gas or whatever. Means we are burning and producing heat energy, then converting into electrical energy. The overall efficiency of the system is only the 33%, right? And the for again we are using that electricity into for the heating purpose. Okay, for heating water or heating any other fluid, working fluid, right? So what we are again the transformation from the first the transformation from the low grade energy to high grade energy, then high grade energy to low grade energy. So losses will be there. So basically, I mean to say, if our requirement is the around the 400 degrees centigrade or the 200 degrees centigrade or 150 degrees centigrade, that that requirement, if it, and we have the enough solar radiations and enough solar radiation, and of course many countries except Canada, Europe, and near to the polar region country, except those countries, we have sufficient solar energy potential, right? So that we can use very easily in our industrial processes, right? So and most of these operations, drying, boiling, washing, sterilization, pasteurization, none of the operation is taking place more than the 200 degrees centigrade, right? So means to at the means for getting the process heat at the temperature of 200 degrees centigrade, 250 degrees is not a good task that can easily we can implement means produced with the help of the solar energy conversion devices, right? So this is the scope basically. Then as per the IPCC, global warming is the most critical existence and environmental issue that our Prime Minister in New York also, he has already committed. We are committed to reduce our CO2 emission by the 30 to 35% by the end of the 2022, right? So that is very as compared to whatever we are emitting in the 2005. So we want to curtail the 30 to 35% of our emission whatever we had in the 2005 by the 2022. So this is our commitment. Definitely, we are working on the towards the government is also working in the same direction, and a lot of results, lots of the good results are already being produced. Okay, so eco efficiency approaches adopt the restraining the emission from the overcoming this challenge, and 1/3 of the total global emissions are released by the industrial sector itself. So this is and I mean to just to say means the more and more energy consumption is there. Energy is produced by the fossil fuel, and that energy we are using for the industrial development of the country's growth, right? So that means the emission is directly from the whatever the fossil fuel over there. So emission raised by an average 1.5% each year during 1971 to 2004, right? So so considering all environmental problem, the requirement for the renewable sources is unavoidable. The utilization of the renewable energy source we cannot avoid. As these renewable energy sources are, we are getting like in the country in India, we have lots of the energy resources. Solar energy is there, wind energy is there, biomass is there. So these are the three main energy resources we have the abundant level. So renewable energy is a sustainable solution for survival of the humankind. It's managed without depending on the conventional sources. So you can say a sustainable development approach we can achieve with the help of the implementation of the renewable energy in the industrial sector and and by implementation with the various industrial activities, right? So this is the very fundamental solar thermal energy conversion system. Uh, this is the solar collecting device over there, and this is over here. It is shows the very simple kind of the solar collector. You may presume this is the flat plate collector, but here it is just the representation of the collection solar collecting devices over there. And the storage tank, of course we need the storage tank, because as we know, the solar energy is an intermittent source of energy, and it is a diagonal and diagonal in nature, because it is available during daytime and not available at night time. And in fact, intermittent means that there are in our, like in our country, in India, we have almost on an average the 60 days for the cloudy weather, right? As per the data, or for the rainy season is around the 60 days, okay, or in any 1 year. So during that period, but basically this is the major problem with the solar energy, but we cannot consider it as a problem. So at this, in the same system we can use the auxiliary system also. Fine. And this system we can overcome the intermittence of the solar energy, diagonal source of energy. These problems we can overcome with by using the storage devices. Okay. So this is that there are the two loop. One loop is the solar collector, and the this fluid is fluid that could be the air or the water, whatever it in the heat is stored in some form with the help of some storage material over there. And this is the another loop. The energy can be harnessed through by the pumping, by supplying the working fluid over there and the boiler. Then again this heat is being used for the generation of steam, and the generated steam is run through turbine, or the like in this way the turbine, or the steam engine. If suppose the heat engine means steam engine is there, it is fine, or the turbine. You can have the mechanical energy, then the mechanical energy further converted to the electrical energy, or otherwise this right. And whatever the heat is, this heat available at this level, that you can use for the secondary uses for the stationary this process heat applications itself. So here basically then 3-4 concerns over there: the size of the collector, type of the collector, storage device, that like how much you want to share from the solar energy. Like in that, like I have already told you, like although we have a lot of solar energy potential, but we overnight we cannot replace all the our conventional sources by the this solar energy or the any other renewable energy equipment. Okay, so because it takes some time, definitely. Otherwise, it will hamper our all functioning of industry sector. Right, the solar energy can be stored directly or warming and all. So, yeah, definitely the kind of the solar, which kind of solar collector, and that means which kind of solar collector means that decide the which kind of the how much, what would be the range of the temperature you need it over there. That will decide the number of or the type of the collector. And the storage system, the how many hours you want heat energy after the after the sunshine or the sunset, the how long you want that much of quality of energy for that much of hour. Okay, so that defines those factors defines the storage size, is the type of the storage material, and the tank size, and all. And in fact, the mass flow rate of extracting this, and the temperature, working flow, the capacity of the system, load factor, the total, how much load you want to replace from the overall load. It could be the 10%, 20%, 50%, and whatever that depends on your design. So, and in fact, one more thing is the specific location specific. Location is very important for this solar energy conversion device. Accordingly, when you have to install the solar collector, solar collecting devices, right? So this is very fundamental basic system for the solar thermal energy conversion system for that. Okay, so And now this is very important slide, like the various processes in the in different industry where the solar thermal energy can be utilized to fulfill the energy demand, required energy demand. Okay, so dairy, tin food, paper, textile, chemical, meat, beverage, flour, and product by timber by product, brick, rock, and plastic refinery and petroleum refinery could be over there. And in fact, the chemical industry are there, so that we cover that over there. So main processes almost the all some of the processes are very common over there, like for the dairy industry, pasteurization, sterilization, drying, concentrates, these activities, sterilization, pasteurization, cooking, bleaching, tin food, paper, cooking, drying, boiler, feed water, bleaching, drying, fixing, pressing in textile industry. These are all the processes. Basically, the heat is involved over there. That's why I'm just telling you all these processes in these industries. So chemical, soap, synthetic, process heat, washing, sterilization, cooking, again the beverage and the washing, sterilizing, pasteurization, and the again the sterilization. The timber by product, the thermo diffusion beam, drying, preheating, curing, bricks and block, and you will be and drying is very important process among all these in all these industry, because you will not believe almost around the 35% of the total heat requirement is goes to the drying process itself, right? So it is the very, and in fact the drying is very energy intensive process, as you know how much energy is needed to evaporate the 1 kg of water. That is the 22,000 kilojoules something, right? So joule per kg of water. So that is basically the latent heat of vaporization. So this much of heat, energy you need to evaporate the one kg of the water. So now these all the thermal process or the all the process heat involved in all these processes can be incorporated very easily. I will show you with the help of solar energy itself, right? So this is okay, it's fine. Solar to thermal and solar to electrical energy conversion path. There are three parts. Solar photovoltaics, I have already discussed. There is a direct conversion of energy to electrical energy. The solar thermal collector is about the solar thermal collectors, and my talk is basically related to this one only. A hybrid collector, definitely because of this solar photovoltaic system, as the temperature increases, 0.4% decrement of the conversion efficiency by the increment of the 1 degree of that solar cell. So this, at 25 degrees centigrade, the solar photovoltaic cells works perfectly. If suppose the 1 degree temperature is raised, then definitely the 0.4% of conversion efficiency will be degraded. So this is the rough estimation, a thumb rule basically. And in fact, at the same time, what you can do, by cooling this solar photovoltaic cell with the help of the air or the water, and the whatever the energy is recovered, the heat energy recovered by the air and water, that you can use for your industry purpose also, right? So by that way, at the same time, the solar photovoltaic systems enhance their energy conversion efficiency, and you are getting the thermal energy. So this kind of the hybrid collector, and now these days, many people are working over there, and these technology are very useful for the Leh Ladakh region, right? For the Leh Ladakh region, Pune and Bangalore, this kind of technology are very successful for those regions. Yes. So solar thermal collector, these are the basic or the heart of the any solar energy conversion device system. These are the heart basically. So solar radiations means short wave radiations are converted into the heat energy, okay, with the help of concentrating and non-concentrating type collectors. What are the non-concentrating collector? Flat plate collector, compound parabolic, regular type. These are the non-concentrating type collector, right? And the concentrating collector means the parabolic type, linear Fresnel, parabolic disk, PDR, central receiver, or the heliostrate field reflector, HFR, or sometimes this is called SPT, solar power tower, right? And definitely we have some advantage of these non-concentrated type collectors over this concentrated, because these kind of these non-concentrating collector, flat wheel collector, compound evaporative type collector can work even though in the diffuse radiations also. Solar radiations have the two component, means sometimes it is called the global solar radiations, and it can break into, it has the two component, beam radiation and diffuse radiation. For the non-concentrated type collector can work in the both kind of the radiations. However, in the concentrating collector works only the beam radiations only, right? At the same time, this concentrating collector have another advantage. It can reduce the cost of the absorbing surface, because here in this case the absorbing surface is less as compared to this non-concentrating collector. But on the other hand, what is happening over there, the reflector cost is increase over there, because a reflector is degrade very fast, right? So degradation of reflectance is there, because the reflectance of the solar surface degrade with time, hence periodic cleaning is required over there. If suppose the place the Jodhpur is there, because in there the wind is blowing, and or in fact the wind is carrying a teeny particle of the dust over there, so it rubs directly, and it degrades the surface also. So reflectivity gets reduced over a time. Such kind of problems are over there. But on the other hand, the concentrating collector are economical in terms of the solar collector area. Reflecting surface is required less material. Already told you the cost per unit area of the collecting surface concentrating system is less than that of non-concentrating. So these are pros and cons of the both kind of systems. And in fact, these non-concentrating collectors are very useful. In combination of these two, these three collectors, we can achieve the temperature in around of the 300 degree centigrade. At 300 or the 250 degree centigrade, we can easily achieve with the help of the parabolic this evacuator type tube collector. Okay, if suppose the application is more than the 250, then we need to choose any kind of this technology, parabolic, linear fashion, or parabolic dish. Parabolic dish and center this is with a high temperature application. Is more than the 600 or 700 degree application is there, and we need to choose this parabolic center receiver type of systems. So just have a look. This is the basic or very fundamental of the convergent solar energy convergent device. Flat plate collector is over there, glass cover. There could be the a single layer, double layer, triple layer, that depends again for the how based on the calculation. Generally, the more than two glazing is not required over there. The absorbing tubes, back plate, the insulation to reduce the bottom and side losses over there. Solar radiation are coming. Solar radiations are coming first through this glass plate, glass cover, and these glass cover have the property of allowing the shortwave radiations then fall on the absorber plate, and all these shortwave radiations are converted to the heat energy. Then it emit the long wave radiations. And the speciality of this glass cover is it do not allow to escape these long wave radiations. So greenhouse effect is created in the micro level over there. So because of this greenhouse effect, so and whatever the heat is developed over on the surface is transferred to the working fluid, and which is flowing through these tubes over there. This is sometimes these tubes are called the riser. And the material, the property of these materials definitely defines the working temperature. Of course, the copper tubes there definitely thermal conductivity is high, and more useful, and the high temperature you can attain over there as compared to having the aluminum or the galvanized or any other material these tubes. Okay, so in the same way, the compound parabolic collectors are over there. So this is the reflector and absorbing surface is there. This is the absorbing tube basically, and the compound parabolic reflector. Radiations coming from all the direction will concentrate over this point. This is the focal point basically, and from through which this absorber tube is passing through which, right? So this absorbing tube basically covered with the concentrated glass or cylindrical glass to reduce the conductive and reduce losses over there. Fine, and the insulation is there. So this kind of application is very useful up to the temperature of the 250 or to 300 degrees centigrade, and this is the acceptance angle over there. This is the mechanism. The evacuative collector is another device. Of course, the very useful for getting the temperature in the range of the 200 degrees centigrade. Definitely, this kind of technology is very useful, and easily you can easily install. And then means these evacuative tubes collectors means the combination of the two different tubes can be the collector over there, and you can join as many of number of the tubes required as per your desired temperature or the desired application. So this is the parabolic turf collector, another device for the power generation. If suppose these solar photovoltaic, this parabolic and this and flat plate, these are for the water heating or the air heating collector, or the some application like the refrigeration air conditioning. These are enough. These three kind of the systems are enough for the refrigeration air conditioning and all. If suppose you want to develop the power, it means the parabolic turf collector, parabolic turf collector, linear flexible collector are able to generate the power. That means electricity itself. The parabolic disc reflector is a very known technology for the Stirling type engine. You can run the Stirling type engine, because in Stirling type engine the working fluid is the air. The expansion and contraction of the air is basically operate the this piston. Okay, so over there the heliostatic field device, all the mirrors over there, and these are mirror are concentrating over the surface. The temperature over the surface is around the 600 to 700 degrees centigrade, and through some system or the heat exchanger, this heat can be extracted to the to generate the steam for running the turbine later on, or the same mechanism as the conventional system. So these are basically the solar energy to heat solar thermal energy conversion systems basically, and you can choose as per your application. So now one more thing, the concentration ratio is another factor. As the concentration ratio is increases, your temperature of the working fluid or the attainment of the temperature will increase. So like in the flat plate collector, ETC collector, evacuated tube collector, this is the compound parabolic collector. So algebraic surface, flat, and tubular. Tabular insert, this is tubular basically. This is stick. So tubular is there. The concentration ratio 1 to 5 over there. Up to the 80 degrees centigrade, you can this flat collector are able to produce this much of temperature. The ETC is 200, and the more than 200 is required. The CPC is 240. So and the PTC, parabolic reflector, linear flexible collector, parabolic disc reflector, and this heliostatic reflector for these. Absorber, tubular. These are the tubular type, because the line focusing is over there. In fact, these are the single axis tracking was there, and this is the point focusing. You need for the point focusing, you need to two axis tracking over there. The concentration ratio keeps on increasing from here to here. Just to see, the maximum concentration ratio is 45, and this PTC can able to produce the temperature in the range of the 300 degrees centigrade. The LFR 250 degree temperature can be attained with the help of that with the concentration ratio of the 40. With the PDR having the concentration ratio in the range of that 100 to 1000, and it can easily produce the temperature in the range of 100 to 500 degrees centigrade. Okay, so LFR up to the 2000 degrees centigrade you can achieve with 1500 concentration ratio. So this is very important. Basically, the concentration ratio, that is the ratio of the it is a ratio of area reflecting surface to the absorbing surface, right? So as the absorbing surface is less, that means that this denominator value is lesser. That means the concentration ratio keeps on increasing. So now this is almost the same kind of system over there. The solar thermal collector integrated with the existing heat supply. This process heat can be 1, process heat can be 2, process heat can be 3. And in fact, what is happening over here? This is the means the solar energy you can implement with the help of this boiler directly on the boiler over there. You can integrate in the conventional boiler. All right. So this is the center for the process heat 1, process heat 2, and process heat 3. If suppose the temperature over here over here is very less. Then you can attach another solar collection device over here at the side for the reading its temperature for this for this process. So or otherwise, as per the availability of the heat at this point, this point, you can decide the different activities of the industrial sector, right? And then there is. So this is simple kind of the layout. The solar thermal collector integration is basically for the different application: solar water heating, district heating, solar refrigeration, desalination, solar heat in the industrial process, right? And this is the high temperature application, and SFD, this is the low temperature application. All application taken place at less than the 100 degrees centigrade, but except this process solar heat in the industrial process. Okay, so this right. So now these are very important figure just to see over here for the solar water heating. Wonderful. Please mute. Please mute. Yeah. So solar water heating has the many applications, like in hospital. You need to have always almost the warm water or the hot water for the sterilization, and many more things are required the hot water. But for the hotel, so solar water heating system for the hotels. Another very promising application is that is for hotel and all. Mm, right. So so now this integrated solar collector storage and the thermosiphon, these are the passive, and in fact the solar water heating could be the passive or an active type system that depends on your again the requirement. So direct circulation is needed for the active, means some pumping devices, you need to have some pumping device. Indirect water heating is again the pumping the air system. So flat field collector, evacuated collector, and compound parabolic collectors are enough, have the potential to fulfill your these kind of the application requirement, right? So such and the space heating, solar space heating or space cooling, of course the FEC, EPC and EPC, these are enough, and the PDR also, parallel disk reflector also, you can for the mechanical system. That means you need to generate the high steam temperature, steam at the high temperature for generation of the that for movement of the system itself, for the mechanical for mechanical power, right? So for that purpose, you need to have the steam. The PDR is sufficient. So in that way, most of the systems. Please mute yourself. Please mute yourself. Dr. Prashant, please ask participants to mute themselves. So right, so space heating, service hot water, air heating, heat pump system, water heating, absorption, mechanical power. These are all like up to this absorption, space heating and all. So this flat plate ETC and CPC are sufficient to fulfill their requirement and temperature at that level. And if suppose the mechanical power, you need to some mechanical power, you need definitely some movement. So that in that case, the steam is really needed. Okay, like for the compressing and all compressor. So for that purpose, you can have that. That is so. Solar refrigeration, again the absorption, the similar kind of things. FEC, these are sufficient because that up to 240 degrees centigrade you can easily achieve with the help of the compound parabolic, and ETC the 200 and up less than the 200 degrees centigrade applications there, and then FEC. These are all the very very easy device, right? And as far as concerned with the solar distillation, the solar still, multiple effect boiling, multi-stage flash, vapor compression, these three devices can fulfill these all operations for the solar distillation. Solar energy system or the solar energy application in case of this industrial process heat. Yeah, this is the very important over here. like if suppose the industrial process heat is there, definitely it could not be the passive type system, right? So mm, you always have the active system only, because the you need to have the continuous supply of the steam or continuous supply of the heat through either to the air. The air could be the media, or the water could be the another media. Okay, so if suppose the temperature more than the 240, the definitely LFR, the PTC is required up to 300 degrees centigrade. So most of the process heat applications, the steam generation, industrial air and water system is covered up to the PT seats, and parabolic truck collectors are enough or sufficient. However, one limitation is over there. If suppose you do not have the additional space or the rooftop or anywhere in your industry, definitely solar energy could not have any support. Okay, because you need to have that additional area. Area can be any place, or sometimes and sometimes the area. Suppose you do not have the open surface area like the rooftop or the some other non usable area. Then the building integrated surface is also there, but it is not in practice in India, in our country now these days. But the transfer type of collector you can have, and transfer type of collector have the another application, very good application in case of the European country, right? So now, for the industrial heat demand by the temperature range of solar process, the heat application, this is very important slide. See all the process in the different industry: dairy, tin food, paper, textile, chemical, meat, beverage, flour and byproduct, timber byproduct, brick or the oil refinery or plastic industry. This is look at over here. For example, the dairy industry. Okay, in the dairy industry, the maximum operating temperature is 180 degrees and 180 degrees centigrade. That is for the drying. Okay, for achieving 180 degrees centigrade on up to the compound parabolic collector or this ETC are enough. Okay, so that hot air you can supply for the drying purpose. And I have already told you drying is very energy intensive process, and almost the 32% of all the process industrial energy is consumed in the drying process only. The most of the industry. Like in that way, the tin food, sterilization, pasteurization, cooking, bleaching, none of the process is conducting in more than the 120 degrees centigrade. Okay, for 120 degrees centigrade, the FPC and the ETC is enough. Okay, evacuator type collector is enough. For the paper industry, definitely another over here the drying, but the drying is not cannot be the more than the 80 degrees centigrade, otherwise it will degrade the quality of the paper. Okay, so this is very this process we have to be take place very carefully. Okay, the rate of heat supply has to be maintained. Okay, directly we cannot have this. So boiler feed water with the 60 to 90% bleaching the 150 degrees centigrade, and this maximum operation taking place in the paper industry is 150 degrees centigrade, and the tin food to 120, and over here the dairy is 180 degrees centigrade. And likewise in the textile, mm, likewise in textile, bleaching, drying, digging, and dyeing, fixing, and pressing. These are the operations. And just look at over here the maximum temperature, maximum operating temperature is the 180 degrees centigrade for the fixing. On the other hand, the drying is taking place at the 100 to 130 degrees centigrade. And so for this application, just to see over here, only the these three kind of the lightweight collector are sufficient to produce the required whatever the required heat energy. And like for example, in the chemical industry, soap, synthetic rubber, process heat, and preheating. Just to look at over here, the maximum operating temperature is the 200 degrees centigrade. So for the 200 degrees centigrade, clean refreshment character or the CPC are enough. For the meat washing and sterilization, again the less than the 200 degrees and 100 degrees centigrade, and this is for the ETC is enough. The beverage, the washing, distilling, and pasteurization 70, the flour and all. Let's look at over here this brick and block. Now, yeah, timber is another timber by product for the thermodiffusion beam or the drying is taking place for the 100 degree centigrade. For this kind of application, with this bulk in the drying is a greenhouse drying system is very useful. And I am happy to share here with you Dr. Prashant Singh Chauhan. He is my student who had worked on the greenhouse drying system, and we have designed many kinds of greenhouse drying system. And greenhouse drying systems are very useful for the industrial drying of the industrial drying of the spices and the herbs. These are very effective systems, right? So bricks and blocks, this curing, and this temperature is a little bit higher, the 140 degrees centigrade. And in this temperature, we can easily get the compound parabolic or the PTC type. The oil and refining, the storage, handling temperature, preparation, distillation, separation, and all these temperatures occur not more than the 250 degrees centigrade and in 220 degrees centigrade. So that with the help of this slide, I want to conclude that all the operation means most operation in these industry can be easily fulfilled by the solar energy itself by the implementation of the simple devices, okay, along with the storage system, right? So this is the possibility of simple simple solar thermal energy storage system. This is the same thing. This means the storage importance of the storage device. I have already told you, because the intermittence of the source of this energy, a diagonal source of energy. Okay, so that so you can have this solar energy for the support. I'm not asking you to directly replace all whatever the conventional system with the solar energy system. So it is not the right idea, right? In the present time. So partly you can implement. You can do that. So a hybrid solar collector and the fossil fuel system with the thermal energy storage. Okay, this is a boiler and thermal energy storage system over here, right? This boiler can be connected with the thermal energy storage, and this networking could be there. The solar collectors are connected with the thermal energy, and directly this thermal energy storage, and this thermal energy storage can connect with the boiler, the conventional boiler, and this conventional boiler also connect with the auxiliary energy devices also, and this is thermal network like that. So thermal energy storage could be based on the method of the storage, could be the temperature range. Okay, so energy storage is another very important for the industrial aspect, because in industry you need to have process heat or the high temperature requirement. High temperature requirement is over there around the clock. So in that case, you need to have this solar thermal energy storage should be integrated with the heat storage devices, and this could be the active, direct storage, active indirect, or the passive storage, or that in the temperature, low temperature, medium temperature, high temperature, and these all depends on the type of the system, type of the media, type of the material. So this could be the sensible heat storage, and again the sensible heat storage application based on the liquid based or the solid based system, or the latent heat, the organic or inorganic based system, and again the thermochemical heat storage materials are also over there. So in that way, you can implement the solar energy with the help of the solar energy converter. Now let us come. Let me check the time. Yeah, still I have some more time. Right, this cost of the different. Now let us talk about the cost of the different thermal collector in India. Just see over flat plate collector. In India is the $180 per meter square of the collector area. The compound, again the 333. It is more than the China, definitely, because more than the China means China is now these days hub of all the technology, and the European is much higher. However, in case of China, European and India is much means cheaper. Like the evacuated tube collector, and most of our evacuated tube collector or evacuated tubes are importing from the China only. Okay, so that kind of a development we can do over here itself. Okay, with economics also. Okay, so parabolic disk fixed type in India, the tracking is always have the more more and more money is involved for tracking parabolic disk. Definitely, it should have the 2-axis tracking for the maximum harness of the solar energy itself, which is a bit higher, 300 to 600 USD dollar per meter square character area, right? The parabolic trough is again cheaper than the European country, the 270. The parabolic trough is not a very tough design, because this totally depends on the parabolic equation itself, right? So it is based on that you can easily fabricate it at your home itself, right? So linear Fresnel reflector again have some technology over there. Like in that way, if we are talking about the sustainability and all the saving of our environment in terms of the annual CO2 emission saving from the different industrial sector, just to see there the potential of the CO2 saving in the dairy in India, the 32 to 144,000 tons of the CO2 equivalent. So 144,000 tons of the CO2 equivalent, this is a huge amount. Annually you can save this much of the CO2 emission from dairy industry with by the implementation of the solar energy conversion devices. And as far as concerned with the paper industry, just to see in paper industry 40,000 tons of the CO2 equivalent you can save by implementation of the solar energy itself. So as far as concerned with the textile, it has a huge potential of the saving of the CO2 emission. 7,000 up to the 7,448,000 tons of the CO2 can be easily easily reduced or easily avoid by implementation of solar energy devices. So uh, uh, I have to ask organizer how much time I have. Uh, so based on that itself, I would like to continue. Dr. Devin, Dr. Prashant Singh, how much time I have now? Please.
Hello. Hello.
Yes.
Yes.
How long can I continue?
You can continue till 1:30, sir.
Okay. That means I have another 10 minutes, 10-15 minutes. Okay, fine. I have another talk in the tomorrow also, tomorrow evening. So just I want to introduce over here the drying. As I have already told you, the drying is a very essential process in any kind of the industry. Okay. And in fact, for the preservation of the agriculture crop, it has its own utility, and it is the ancient process for the industrial crop and agriculture produce, for the drying of agriculture produce by the spreading the crop, grains or fruits from spreading on the ground itself on the open sun. So this is that is the open sun drying process, but it is not safe because the quality of this product is very degraded, and you can have many degradation during this and to a certain temperature, up to a certain moisture content, you will not able to use, because and by the time the stagnation is occurred, the steady state condition is occurred, means you need to control three factors. One is the temperature, surrounding temperature, another one the surrounding relative humidity, and third one is the flow rate of the air, which is the moisture carrying moisture carrying carrying capacity basically. So on the other hand, it can be say that this is the relative humidity itself. Okay, fine. So you have to optimize these three parameters. And drying, already I told you that this is a very energy intensive process. For evaporating the 1 kg of water into the in the form of the steam, you need to have at the 100 degree centigrade, right? You need to have the 22,000 joule per kg. Okay, joule. This much of energy you need to have to evaporate the 1.1 kg water at the 100 degree. If the temperature is higher, definitely this value would be higher. So such a kind of the application or the industrial application or drying, you can easily implement. You can easily implement the solar drying technology and all. So now this was for the solar agriculture crop and industries such as the textile production. Again, the textile production, the drying is taking place in around the temperature of the 130 degrees centigrade. Okay, so 130 degrees and they're dairy process, cement production. Yeah, cement production, you may say the the minimum requirement of temperature 600-degree temperature. I will show you in my later slide, and how that in the cement production it can be incorporated. The clay bake production, again you need to have a very high temperature in the range of the 1200 degrees centigrade. And in fact, there are also the 1200. Some clinking is a process with on the cement production. You need to have the very high temperature in the range of the 1200 degrees centigrade. And 1200 degrees centigrade also you can easily achieve with the help of the solar energy conversion device. Like tile production, this again the clay and all the wood and timber processing. This is basically timber processing, drying only the wastewater treatment, of course. Wastewater treatment, the sludge is there for the and sludge for drying the sludge, and sludge is very useful byproduct. Okay, so that again you can use the solar energy for converting it into the char, or in fact the wastewater to evaporate the water. You need to have some energy itself. So solar energy directly you can use. The biomass treatment again is needed for this. For example, this gasifier. So you need to have reduce the moisture content before feeding into the this gasifier, right? Otherwise, the some part of its calorific value will be wasted in the evaporation of the water itself. So that such kind of the problems you can avoid with the help of the solar drying. And before solar drying, or means before solar drying practice in the industry, and the drying were taking place in solar electricity, fossil fuel, natural gas, and wood on the bark forest residues, forest residual also. Okay, and solar is the no. So reason for implementation of solar drying, the depletion of solar this natural fuel sources, fossil fuel, definitely rising the fossil fuel cost. This is another reason. Okay, most of our foreign exchange goes in the sector itself. The environmental degradation. This is the common human problem for all. Greenhouse gas emission, and these are the problem for all of us whosoever is live in this earth. Okay, so major challenge, intermittent nature of the solar energy that I have already discussed. With that you can avoid with the help of either energy storage system, or using energy systems, or using or introducing some other renewable systems, whether it could be the wind energy, it could be the photovoltaic systems also. So such kind of things are known as the hybrid solar drying system. So in the solar drying, some other kind of the energy related media is implemented, whether it is the storage device or the photovoltaics, or any kind of thing, like in that way. So this is called the hybrid. So I will give you a few example of the hybrid solar dryer. So now, just you see over here, in case of the manufacturing process, the industrial dryer consumes significant portion of the total energy used in the manufacturing process. This is for the manufacturing process, which is on average the 12% on an average, and for the drying purpose only, the 12% of the total energy consumption in the industrial sector is goes for the manufacturing process. Okay, right? For instance, the energy used in the drying industry was estimated 128 into 10 to the power 9 megajoule per year for in the UK. Okay, so UK. Then this table is speaks about the UK and France energy consumption for the drying purposes in the different industries. Let's look at over here. This is for the French industry. This is for the British industry and total. And now on the food and agriculture. So this much of megajoule, 46.3 into 10 to the power 9 megajoule per year is used for the this much of energy is used for the drying purpose in this industry, the food and agriculture. Huge consumption is over there for the drying itself, right? As far as concerned with the British industry, this is the 35 into 10 to the power 9 megajoule per meter per year. And for chemical, textile, just to see, for the paper industry, very high. Okay, for the paper industry, it is very high, the 38.8 into 10 to the power 9 megajoule per year to this or this. So now just to look at over here, percentage due to drying. So percentage due to drying, percentage of energy consumption due to drying is 12% of overall the industrial consumption. 12% goes for the drying purpose in the food and agriculture, 6% chemical, 5%, and just see over here the paper industry, the 33% of the whatever the energy consumed in the drying, whatever energy consumed in the paper industry is goes for the drying only 33% of the total, one third of the total energy consumed in the paper industry. Like in that way, the timber drying is another 11%. So overall, on an average, we can say that 12%, 12% on an average, the energy consumption of the energy of the total industrial consumption it goes in the drying purpose only in the UK and France, French area. Okay, so like for example, this textile, because these are all these are very developed country, even though these are very developed country. But this much basically this is very necessary. Without this much of consumption drying, and many operations are taking place for the drying itself. Now the textile industry, the energy requirement for the textile bat process, these are the textile or bat process basically. Just to see the energy requirement in terms of the gigajoule per ton output. So huge amount of the gigajoule, up to 20 dyeing, continuous thermosolar dyeing the 20 gigajoule per tons of this. So like in that way, just my intention is to show this slide is to just check out this figure. A lot of the energy is required for the this drying process itself. For the I will give you some example also, some more example. Okay, so, like this is another developed country, like for the textile. Okay, for the textile sector, the thermal energy used in the drying, just look at over here, and drying just to means drying is taking place in the temperature of around the 100 to 130 degrees centigrade. Okay, so just you see over here the product heating, and in product heating you need to have the 16.6%. Product drying you need to have 17.2%. Wastewater loss you need to have 24.9. So like in that way, just to see over here, suppose the product drying, this 17.2% share is for the drying only in case of the textile industry in Japan. Okay, Japan. So now these words, just I want to what to say. Suppose I continue. So shall I continue or tomorrow itself? Because I want to talk about the different industrial application of the solar energy.
If you wish, you can continue tomorrow, sir, if possible.
Okay.
Thanks for giving us insight about the scenario of solar energy consumption in India and across the world, and giving us information regarding the utilization and different kinds of the solar uses in the industry as well as for the purpose of domestic. So I sincerely thank you, sir, on behalf of the whole team of this workshop and Gaya College of Engineering. And now we have the lunch time, and after that we will resume this session at 3 p.m. with the talk of Dr. Ashish Shukla, sir, from Coventry University, and his topic will be low temperature heat harnessing for building. So thank you, sir. Thanks, Anil, sir, for your time.
Thank you, Dr. Paul, for thanks again for providing this opportunity. Thank you very much. See you tomorrow.
Thank you, sir. Thanks.